Hello student, welcome to the lecture number 24 in Petrochemical Technology. So here we will talk about the thermal cracking. This is our new topic. So thermal cracking in the refinery is very important unit where we in with the application of heat we crack the heavier hydrocarbon. So into this slide we will talk more detail about the thermal cracking. So if you talk about the thermal cracking, how it is defined, the thermal cracking is a refining process that involves the breaking down of larger hydrocarbon molecule into smaller ones. So smaller ones molecule of the hydrocarbon are more valuable, more useful molecule through the application of heat. So this process is used in oil refinery to convert heavy, high boiling point petroleum fractions into lighter products such as gasoline, diesel, and various petrochemical feedstock. So there are mainly two type of thermal cracking. So first one is vis breaking. Vis breaking is a mild form of thermal cracking that operates at relatively lower temperature and lower pressure. So vis breaking is a unit that is having the cracking application that operates at lower temperature and lower pressure compared to the cracking method. So the primary goal of the vis breaking is to reduce the viscosity of heavy residual oil and decrease their boiling point range to produce more valuable product. So this process involves heating the feedstock to temperature around 870 to 900 degree Fahrenheit and 465 to 480 degree centigrade for short period. So and typically less than an hour. So this is heated for very short period, that is less than an hour, and then rapidly cooling the product. So after doing this process we get the lower viscosity residual oil and lower boiling point residual oil or petroleum product. And next, the another type of thermal cracking is that is delayed coking. Delayed coking is more severe thermal cracking process used in to convert the heaviest fraction of crude oil, often residual oil, remaining after other refining process. So it is converting the heaviest fraction of the crude oil. The heaviest fraction of the crude oil is heated into the delayed coking unit and converted into the lighter product. So this process involves heating the feedstock to extremely very high temperature, that is usually around 900 to 950 degree Fahrenheit or 480 to 510 degree centigrade in large drum. These are called cokers for extended period, typically more than 24 hours. So here in this process the feedstock is heated for a longer time, like more than 24 hours, and this is the high temperature and high pressure operations. So temperature range is 900 to 950 degree Fahrenheit and 480 to 510 degree centigrade. So the high temperature causes the hydrocarbon to break down into lighter fraction and solid residue called coke. The solid residue that is deposited at the bottom of the coker, that is called the coke, and the lighter fractions are recovered as valuable products such as gasoline, diesel, while the coke is removed for further processing or used for as a fuel source. The coke is can be recovered for the further processing. Further processing you can again improve its viscosity and again you can reform it into the valuable product if it is available, or it can be used as a fuel source. So coming to the next slide, the thermal cracking processes are characterized by the application of high temperature without the presence of a catalyst. Here for the heating purpose the catalyst is not required. So these processes break larger hydrocarbon molecule into smaller one that through the cleavage of the carbon-carbon bond. So carbon-carbon bonds are broken due to the high application of the heat, resulting in the production of lighter or more desirable hydrocarbon. So while effective in converting heavy fractions into lighter products, the thermal cracking tends to produce higher proportion of unsaturated hydrocarbons. So thermal cracking is producing the higher proportion of the unsaturated hydrocarbon and can yield some undesirable byproduct like coke, which needs further treatment or disposal. So coke is a unsaturated hydrocarbon. So this can be further processed, and this is the thermal cracking process is yielding the high amount of unsaturated hydrocarbon. So these thermal cracking process play a significant role in maximizing the yield of valuable product from heavier crude oil fractions that would otherwise have limited use due to their high viscosity and high boiling point. So here this is a systematic diagram of thermal cracking setup into the refinery. You can see this is the liquid feed, that is the heavier fraction of the crude oil. This is being pumped to water, and then further it is being pumped to the unit. And here this is a different type of heaters that are due to the heat application, these products are being heated into this. This is a compressor, this is a air fuel filter, and here this is a gaseous feed. So after that, here we are collecting the different type of product that are valuable for the market. So next topic will be discussed into the next lecture. For any question and clarification, you can write to me. Thank you.